Okay, what we're working on today is called approximating log values and using change of base theorem. Okay, so we're approximating log values. Okay, so to start with, if it says if we write log base 2 of 10 in exponential form, you would get 2 to the x equals 10. If we wanted to know what is x, okay, there is no way for us to find that out unless you put it in exponential form. Okay, do we know what exponent on 2 makes 10? No, we don't know that, but we can approximate. Okay, because you do know that 2 to the third is 8, 2 to the fourth is 16. So would we all agree that 10 is somewhere in between 8 and 16?
Yes.
Now, the question here is actually asking you for what is the exponent between. So the exponent would be between the consecutive integers 3 and 4. Okay, so let's do one together. Log base 3 of 25. If you change it to exponential form, it would be 3 to the x equals 25. Between what two consecutive integers does x lie? So what we have to do here is you want to write down what are the values of 3 that you do know. So you know 3 to the first would be 3. 3 to the second is 9. 3 to the third is 27. 25 is somewhere in between 9 and 27. But the answer here is I'm asking what are the exponent values. So between the exponent values of 2 and 3. Okay, you will have some like this on your quiz and on your test. Lots of people will make the mistake and they'll put 9 and 27. It's not what I'm asking. I'm looking for the exponent value. Okay, so exponent value plus it says consecutive integers. So that means numbers in order. Last I checked, we did not count 9 and then 27. Okay? Yes, on today's quiz and your test. Okay, log base 7 of 9 lies between which consecutive integers? So if you rewrote this, this is 7 to the x power equals 9. What do you know here? You know 7 to the first is 7. You know 7 to the second is 49. Is your target in between those? Yes. So what are the exponent values between 1 and 2? Right? This should be very, very simple, I hope. Okay? How about log base 3 of 200? We know that 3 to the third was 27. 3 to the fourth is 81. 3 to the fifth is what? 243. So 200 is right in between that. So between what consecutive integers is the exponent? 4 and 5. Okay? There will be some like this on your quiz today. I think it's just 1 or 2 of them. But you do need to know, like if we were asking about what is the exponent value, it's between 4 and 5. I'm not asking you for an exact value. It's just about, like if you're approximating. Now, the most important thing that we're doing today is actually called change of base. This is a theorem. The reason that we have change of base theorem is because if I was going to ask you to find an exact value, okay, find a log value on your calculator, the only way that calculators work are in base 10 or base E. Most of our answers are not written in base 10 or base E. So we had someone, I don't know who, but they had to figure out a way to change the base so that we could do it on a calculator. This is how we change bases. Okay, basically, if you want to change a base, the base part goes to the denominator, the answer part goes to the top. The new base can be anything, okay? Usually we will want to change them both to be base 10. But if you wanted to, you could change things to be base 6, base 4, base 8, any base you want. Okay, but we will use this most often to change things to be base 10. Okay, now, look on the back. Okay, if you look on the back, it says, let's see where we're at. Rewrite the following using the change of base formula. So I want you to rewrite log base 5 of 7, change it into base 2. So the way you do that is it's always going to become a fraction. So we write log base 2 over log base 2. Then you just have to figure out where does the 5 go, where does the 7 go.
7's on top.
So if you looked at that formula that I gave you on the front, 7 goes on the top, the base goes on the bottom. That's it. That is your answer. And that is all that we're looking for here. Okay, so that's your answer there. Any questions on how I did that? Now, I don't really know why you would ever want to change something to base 2, because we couldn't plug that in on a calculator, but technically you could. Okay, this one's a little bit more real world applicable, because if I want to figure out what is log base 2 of 3, do we know what the exponent on 2 is to get 3? No. But if I change it to base 10, that's log, and you can write in the base 10, but you don't have to. Log base 10 of, which one goes on the top, which one goes on the bottom? 3 on the top, 2 on the bottom. So technically, since this is in base 10 now, I could use a calculator. I don't know if you can really see that. And you could find log of base 3 divided by log of 2. Technically, we could get an answer here. So that would be 1.58 dot 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 dot. Okay, so that's the reason behind change of base. I am not actually asking you to do this. I just want you to be able to convert between bases. Okay, so you're not actually going to have to do this. I just want you to know how to convert between the forms. It's kind of like converting between exponential and log form. You just have to know how to do it. Okay? You can also convert between, consolidate to be in a single base. So if I have the same base here, this can cancel out, and this becomes log, which one's the base? The bottom. Base 7 of 8. Now, that is very different than if I wrote log base 5 of 8 over 7. This is changing, this is the quotient rule. This one is not the quotient rule. So that's where the confusion might come. I do not want you applying the quotient rule here. Okay? This is very, very, very different. That's your answer. Anyone have questions so far? Yes?
So we won't be using a calculator?
No. I do not want you using a calculator at all. No. So you're converting to a form that you could use a calculator, but I'm not actually asking you to do it. If I asked you to do it, then I would literally have to make you go back and every assignment that you've done, since you now know how to actually find number answers instead of in log form, you'd have to do them. So not using a calculator is actually a good thing for this, okay? Because if I let you use a calculator, you would have to do a lot more work on like every problem, because you'd have to change the base and then find the calculator form. So you don't want to do that. Okay, how about number 6? Log base 2 of 6 divided by log base 2 of 10. The 2's go away, and this becomes what? Log, if you write base 10, that's fine, but you don't have to. Log of 6, and that's it. Okay, also make sure that you're not trying to reduce. Okay, the 6 and 10 do not reduce one another. Okay, that's fairly straightforward. How about number 7? I want you to rewrite number 7. Condense it into a single log. What's another way to write natural log?
E.
Log base E. So you do have to rewrite this in a log base E form. Then once you have log base E, these can go away, and you can rewrite this as what? Log base 3 of 4. You cannot write natural log base 3 of 4. That does not make sense because natural log is automatically log base E. So this is bad, okay? The E? Right, we're changing the base. Just like these, it kind of goes away. I'm changing the base. Okay, but you do have to take that pre-step of rewriting it as log base E. Now, for numbers 8, 9, and 10, I want you to actually write these as a single log and then simplify. Okay, so write these as a single log and then simplify them. So for something like number 8, the 8 part goes away. By the way, they have to be exactly the same to use change of base. You can't have like a 2 and a 5. That doesn't work. So this would be written as log base 3 of 81. This is actually able to be simplified. What is the exponent on 3 that makes 81? 4. So your actual answer here is 4. Same thing here. The base 5s go away. log base 8 of 2. Now, a lot of people are going to write that upside down because in your brain, it's easier to figure out if these are switched. But we can't do that. What is the exponent on 8 that makes 2? It's actually 1/3. Okay, now, in case you forgot how to do that, let me show you. Okay, in case you forgot, you would introduce an x. X is the exponent on 8 that makes 2. Make them the same base, so this is 2 to the 3x equals 2. The bases can be dropped, but what's the leftover exponent? A 1. Okay, so that's how we would get 3x equals 1. If you divided both sides by 3, you'd get 1/3. Questions on how I did that? Does that make sense-ish? Okay. How about for number 10? What can I do here? These go away. So the e's basically cancel out. So make sure when you rewrite this, you write it as a log 32. Log base 2 of 32, excuse me. And what is the exponent on 2 that makes 32? 5. Okay, if you're having trouble with your bases and your exponents, that's why that chart is on the wall. Okay, any of the ones that you really, really need are there. Okay, and then the last part, solve by introducing logs. Now, this is where I know a lot of you want like number answers, and you're not going to get them, okay? Leave answers in log form. So if I asked you to solve, how would we solve this? Any ideas? 5 to the x equals 30. Can you make these the same base and drop them? I don't know what 5, the exponent is on 5 that makes 30.
It's between 2 and 3.
I know what it's between. Yes, it's between 2 and 3, but that's not what I want. Oh. So write it in log form, exactly. So if you rewrite this in log form, this would be x equals, x is the exponent on 5 that makes 30. Now, I know you're not going to like it, but that's your answer, and that's it.
Do we have to write it equals?
This is it. Solve for x. Now, if I really wanted to find an answer and I was letting you use calculators, how would I do that? I would change the base, exactly. So this would be written as what? If I wanted to change it to a usable calculator-friendly base.
Log 30 over log 5.
Log 30, which is base 10, over log 5. Okay? I'm not asking you to do that, but this conversion, let's just say, would be very helpful to know on your quiz today. Very important to
Do we
know.
have to like use
This one. No, you're not going to be using your calculators. I'm just saying. If your answer looks like this, and it's a multiple choice problem, and that is not there, but this is, they are equivalent. Comprende? Half of you got that, half of you didn't, but whatever. It's your quiz. Okay, number 12. 8 to the 2x equals 74. Where do you think I start?
Log.
Rewrite it in log form, right? So 2x equals log, what's my base? Of 8 of 74. How do I get that x by itself? Divide by 2. Okay, divide by 2. That is your answer. X equals log base 8 of 74 over 2. Do not reduce because you can't. Okay? Base 8 of 74 divided by 2. Yes, that's your answer. And you're done. I don't want an exact perfect answer. It says leave in log form. Question. You do not have to. Okay, although it did say solve for x. But if you don't put x equals, whatever, I don't care.
You know, sometimes like the exponent, it's like x plus 2.
We're going to get to that right now.
Okay.
Okay, last one, on number 13. I want you to actually change this problem to be e to the x plus 1. Okay, change the problem. Change the exponent to be e to the not just x, but x plus 1. Now solve. You can solve this, and there is one exactly like this on your quiz today. You're good. E to the x plus 1 equals 43. So how would I begin to write this in exponential form? X x plus 1 is the exponent on e that makes 43. Yes?
Why did you put the plus 1 there?
Because I'm telling you, there's a quiz question that has something with not just an x, but a plus 1. So I'm changing the example.
Oh, okay.
Because there's a quiz question and a test question that's exactly like this. So I just want you to see how to do it if there was a plus 1. How do we get x by itself? Subtract 1. Where does that 1 go when I subtract it? This is not the quotient rule. Okay? The quotient rule is if you had something like log base e of 43 minus log base e of 1. But I don't have 2 logs here. So this is not the quotient rule. Yes? No. Because I don't know what you said.
Log e of 43 minus 1.
Now, do you think that I can just write log e of 43 minus 1? What does this tell you to do first? Is this, like, if you read this question, what does it tell you to do?
Tells you to do the log of e first. Oh, what?
Does it? This would mean that you would actually subtract first, and you're not, okay? The log base e of 43, like if you look at this, natural log of 43 on a calculator is actually 3.76. Do I really mean 3.76? Am I really supposed to do the log of 42? Or would I really supposed to do the log of 43 and then subtract 1? Which one comes first? It's difficult to know, right? The log should come first, but this is confusing written that way. You cannot write things that way because it looks like you have to simplify first. So the correct way to write this would be -1 plus natural log 43. Because remember, we don't write log base e, you write it as natural log. So the correct way to write this is -1 plus. Okay, it needs to be first. It needs to be first, not second. Because technically this could be misconstrued as log base e of 42, which is wrong. Okay, that's wrong. Homework for this is going to be worksheet 11, and you guys are doing numbers 1 through 25. You're just doing the odds, okay? You may use these notes on your quiz right now. You will need these notes on your quiz right now. Question.